So what would you say? If you have $50 in your wallet, what's the maximum number of rides that you could go on? What'd someone say? This one you should know. 10, right? And what was your reasoning? How come 10 is the maximum number of rides? What'd you do? Right, you took $50, right? And you divided by $5 per ride and you got 10. Right? So you could go on 8 rides, you could go on 2 rides, you could not go on 11 rides. So starting to think about inequalities, as I jump down to number 5, which sounds like where some of you are stuck, how could I represent the number of rides if rides is x? X has to be less than or equal to 10 rides. That's all I meant. So we're representing kind of the situation using an inequality. And that means that x could be 8, but x cannot be 11. And obviously, x can't be 9.5. You can't pay for and go on 9.5 rides, right? Has to be an integer, but that's kind of in that domain of the problem. What did you say? Can you purchase 8 food items? Did you say yes or no? Okay, why not? What was your justification? Right, 8 times $8 would be $64, right? So that doesn't work. I only have $50 in my pocket, right? My justification was not good on my paper. Okay. All right, what about could you purchase 2 food items and go on 2 rides? What'd you say for this one? So you just did the math, right? 2 times 8 plus 2 times 5 came out to how much money? So it came out to 26, so you have $24 still left to do more with, right? So that's a combination that you could do at the fair. Eat 2 things and go on 2 rides, and you still have enough money to do that. That's where the inequality idea comes in, because there's more than one outcome. Devin could use his $50 one way, but someone else could use their $50 another way. Give another example of a combination of rides and food. What'd you say? Give me one example. Devin, what'd you say? So 8, so 3 food, right? So that's 3 times 8. And then what'd you say? 5 ride? 5 ride, because that would be 5 times 5. Came out to what? 20. How much? $49. So that was a good maximization of using all your money up. Let's say it was your parents' money and I just want to spend it all, right? I might as well do as much as I can do because it's not my money. Now, if it's your money, you might want to have a fair experience, but still leave with $24 left because it was your hard-earned money. Do you guys spend money differently depending on the source? No? Oh, good. You're all careful or whatever with money? You keep the money either way, I say. All right, what about write an inequality to represent the number of food items? What does y have to be less than or equal to? What's the maximum food that you could have bought? 6. I think that you'd be pretty sick to your stomach if you ate 6 items of food at the fair. You think you could get fries, a drink, fried dough, bloomin' onion? Oh, I still think that you're going to be maxed at 6 different food items. I guess to leave, huh? Why? You going to buy 6 fries? Really? Wow. Okay. Eat it different ways. Uh-huh. Okay. All right. So now here is write an inequality. This is where we're getting at. Write an inequality that could represent our combined food and rides. So just like up here, we could have done like 2 and 2. We could have done 3 and 5. This is the inequalities that we're getting at this unit. How much is each x? X was what? X was rides, right? So $5 times every x plus $8 times every y has to be less than or equal to $50 total. This is very similar to one of our linear equations that we wrote when we were solving systems, right? Money amount times x, money amount times y, and less than or equal to 50. So it says, let's look at this on a graph together. So I want to show you the graphing calculator. So the first thing is I can't type this into a graphing calculator. So just kind of really quickly, I'm going to get my 5x to the other side. You don't have to do this. I'm going to show you how to graph these in a minute by hand, but I can't graph it if it's... So I'm trying to graph y is less than or equal to negative 5/8 x plus, I don't know what 50/8 is, so I'm just going to leave it as 50/8. So on your graphing calculator, go to your y equals menu. Oh, shoot, I had it in there from last class. Negative 5/8 x plus 50/8. So I just want to show you, on your graphing calculator, did you know that if you arrow all the way over to this, it allows you to select if you want to do an inequality or a line? So I had practiced doing this on Friday, and I changed it to this bottom left triangle option, which allows me to shade below this line. If you change it to the, let me see this upper right triangle, it's going to shade above the line. But if we're trying to spend less money, we need to go below the line so that we're under $50. So that's a button that you might not have seen before. When I graph it, I can't remember. So this blue shading is shading everything below that limitation of $50. So basically, any of the coordinates that are in this triangle, it has to be positive. You can't ride a negative number of rides. But like I could ride, like this is +2 on the x-axis. So I could just do 2 rides. This is +2, 3, 4, 5 on the y-axis. I could buy 4 food items, or over in this region, like I could buy 2x and 2y, and then I have spent whatever that $40-something. So it gives you a solution of a shaded region. Any possible outcome is in that shaded region. So an inequality allows you to get multiple outcomes that are all possible. Just like up here, we had multiple options of combinations. So that's how an inequality is going to be different than an equation that only has one solution. Does that kind of give you an intro of what we're looking for? We're going to be graphing things that look like this. All right.